The hydroxyl radical, Earth's natural oxidative capacity. When we think of Earth's ability to sustain life, we often picture forests, oceans, and the thin blue atmosphere. But hidden within that atmosphere is a tiny, fleeting molecule that acts as the planet's invisible guardian, the hydroxyl radical, written as OHO. Scientists call it the detergent of the atmosphere because it scrubs the skies clean and keeps Earth's chemistry in balance. What is the hydroxyl radical? The hydroxyl radical is formed when sunlight interacts with ozone and water vapor. In a fraction of a second, this reaction produces OHI, a highly reactive molecule that survives for only about 1 second before reacting with something else. Despite its short life, OH is everywhere in the lower atmosphere, constantly renewing itself. Think of it as Earth's self-cleaning mechanism, a molecular janitor that never rests. The planet's cleaning agent. The most important role of OHH is cleansing. It reacts with pollutants such as carbon monoxide, methane, nitrogen oxides, and volatile organic compounds. Without OHH, these gases would accumulate to dangerous levels, destabilizing climate and choking ecosystems. For example, OHT removes about 85% of methane from the atmosphere, converting it into water vapor and carbon dioxide. It neutralizes toxic gases from wildfires, fossil fuel burning, and industrial emissions. It sets the lifetime of many greenhouse gases, determining how long they linger in the air. In short, OHI is the atmosphere's immune system, triggering precipitation and cloud cycling. But OHH does more than clean. It also plays a subtle role in the water cycle. When OHH oxidizes gases like sulfur dioxide or nitrogen oxides, it produces compounds that act as cloud condensation nuclei, tiny particles around which water droplets form. This process helps initiate cloud formation and gentle precipitation. Unlike violent storms, this is the quiet cycling of clouds that maintains regional moisture balance. By seeding clouds, OH indirectly supports rainfall patterns that prevent drought and sustain agriculture. Cloud cycling is also a thermostat for the planet. Clouds reflect sunlight back into space, cooling Earth, while also trapping heat at night. OH, by helping clouds form, becomes part of this delicate climate regulation, moistening soils and storing carbon. When rain falls, it carries with it the products of OH chemistry. One of the most important is carbonic acid, formed when carbon dioxide dissolves in water and reacts with OH1. This weak acid seeps into soils, where it enhances mineral weathering, releasing nutrients for plants, helps soils retain moisture, buffering against drought, locks away carbon in the form of bicarbonates and stable soil carbon compounds. In this way, OH links the atmosphere to the ground, turning gaseous carbon into stored carbon. Soils become both sponges for water and vaults for carbon, supporting ecosystems while moderating climate. How long has this system worked? The hydroxyl radical has been part of Earth's chemistry for hundreds of millions of years, essentially since oxygen and water vapor became abundant in the atmosphere. It is a cornerstone of the planet's oxidative capacity, the ability of the air to cleanse itself. Studies show that global OH levels have remained surprisingly stable over the past few decades, varying by less than 2% despite massive human emissions. This stability is remarkable, but it is not invincible. The challenge of human pollution. Today, atmospheric carbon dioxide has reached 478 parts per million, a record in human history. Alongside CO2, emissions of methane, carbon monoxide, and volatile organic compounds compete with each other for OH base. Each molecule of pollution that reacts with OH reduces the radical's availability to clean up others. This means that while OH is constantly produced, it is also constantly inundated by the sheer volume of pollutants. Methane alone has more than doubled since pre-industrial times, demanding more OHE than ever before. Wildfires, industrial emissions, and urban smog further strain this natural system. If OHI becomes overwhelmed, pollutants linger longer, greenhouse gases accumulate, and the climate destabilizes. In effect, the Earth's immune system risks being compromised. Why it matters. The hydroxyl radical is a reminder that Earth has built-in resilience. It cleans the air, seeds the clouds, nurtures the soils, and locks away carbon. But it is also fragile, existing for only a second at a time, and yet responsible for balancing the chemistry of the entire atmosphere. At 478 ppm of CO2 and rising, humanity is testing the limits of this natural oxidative capacity. The hydroxyl radical can keep up, for now, but only if we reduce the burden we place upon it. So, when you look up at the sky, remember, it isn't just blue air above us, it's a living, breathing chemical shield, powered by the tiniest radical of all, the hydroxyl radical, Earth's invisible janitor, rainmaker, soil moistener, and carbon keeper. It has kept our planet habitable for millions of years. The question is whether we will give it the chance to keep doing so for millions more. A transparent, nature-based solution from Kamloops. While many geoengineering programs around the world experiment with risky and often secretive methods, such as stratospheric aerosol injections or solar radiation management, one Canadian company is charting a different course. Reduction Tech of Kamloops is proposing a solution that doesn't fight against nature, but works with it. The careful reintroduction of regulated levels of hydroxyl radicals, OH, back into the atmosphere. Unlike traditional geoengineering, this approach is not hidden, not covert, and not toxic. The team is committed to full transparency, operating under national regulations, and openly sharing their science. Their vision is simple, yet profound. Restore the atmosphere's natural oxidative capacity, allowing Earth's own cleaning system to permanently remove greenhouse gases and pollution. The Quadruple Mitigation Plan. Reduction Tech's strategy is designed to scale responsibly. They call it their Quadruple Mitigation Plan. Lamp posts, urban infrastructure becomes a platform for localized OH dispersal, cleaning city air where people live and breathe. Small stacks, industrial exhaust points are retrofitted to neutralize emissions before they spread. Vehicles, mobile sources of pollution are paired with mobile solutions, reducing smog and greenhouse gases directly at the tailpipe. Aerial release. Eventually, controlled dispersal at altitude will expand the reach, enhancing atmospheric cleansing across regions. Each step is designed to comply with national safety standards, ensuring that the process is as safe as it is effective. Science rooted in deep time. The science behind hydroxyl is not new. In fact, OH has been part of Earth's atmosphere for over 3 billion years, quietly maintaining balance long before humans arrived. By aligning with this natural system, Reduction Tech offers what they call a permanent exit strategy, a way to replace short-term, high-risk interventions like SRM and aerosol injections with a solution that is both natural and enduring. Hydroxyl dispersal is not about engineering a new planet, it's about restoring the one we already have. By amplifying Earth's own oxidative capacity, Reduction Tech envisions cleaner skies, healthier soils, and a climate system that can once again regulate itself, safely, transparently, and in harmony with nature. Hydroxyl dispersal is not about engineering a new planet, it's about restoring the one we already have. By amplifying Earth's own oxidative capacity, Reduction Tech envisions cleaner skies, healthier soils, and a climate system that can once again regulate itself, safely, transparently, and in harmony with nature.